All right, let's dive right in. Out of all the huge mysteries in physics, maybe the biggest, the most fundamental, is time itself. I mean, why does it only move forward? It's relentless. Well, a fascinating new model called Conformal Emergent Reality, or CERM for short, offers a pretty radical answer. It says the forward march of time isn't just some rule the universe follows, it's literally baked into its geometric architecture. And it all starts with a question that is so simple, but so profound it has kept physicists up at night for over a century. Why can you remember what you had for breakfast yesterday, but you have no clue what you're going to have for dinner tomorrow? This simple, everyday observation points to this deep, fundamental asymmetry in our universe, the one-way flow of time. In physics, this one-way street has a name, the arrow of time, and for decades it's been a real head-scratcher. See, the weird thing is most of the fundamental laws of physics, we're talking gravity, electromagnetism, they don't care about direction. They work perfectly fine forwards or backwards. So what gives? Where does this undeniable forward-only direction that we all experience actually come from?
Well, the traditional answer is something called the past hypothesis. And it basically just says the universe started in a really orderly state for, some reason we don't really get. And ever since then, it's just been getting messier. But that feels like a bit of a cop-out, right? It's more of an observation than a real explanation. It doesn't tell us why. And this is exactly where the CERM model comes in, with a totally new perspective, one that isn't based on some starting line assumption, but on the very geometry of space-time itself.
So this brings us to our first major clue in solving this mystery. CERM suggests that the time we see on our clocks, what scientists call cosmic time, might not be the most fundamental kind of time there is. It hints that there's a deeper, more primitive clock ticking away at the very heart of reality.
The model draws this really key distinction. On one hand, you've got cosmic time, the T that we all know. It's measured in seconds, minutes, years. But then there's this other thing, proto-time, represented by that Greek letter, tau. And this is something much more fundamental. It's a pure sequence of events that's hardwired right into the geometry of the universe.
So what does that mean? Proto-time isn't about duration. It's all about order. Think of it like this. Imagine you have a ruler with numbers on it, 1, 2, 3, 4, but no units. It doesn't know about inches or centimeters. It just knows, fundamentally, that 2 comes after 1 and before 3. That's proto-time. It provides the basic before and after for the entire universe, a sequence that exists even before what we think of as physical time emerges.
Okay, so if proto-time is the track, the sequence for the universe to run on, what's the engine? What's actually providing the push that drives events forward along that track? A train on a track doesn't go anywhere without an engine, right? This brings us to our second clue, and it's a whole new take on a famous principle in physics.
It's called the quantum geometric uncertainty principle. Now, when you hear uncertainty principle, you probably think of Heisenberg and how it puts a limit on what we can know about a particle. But this is a whole different beast. This principle isn't a limitation on our knowledge. It's a fundamental, creative force that's literally built into the fabric of reality.
Now, don't let the equation here intimidate you. The idea behind it is what's truly mind-blowing. What it's really saying is that it forges this unbreakable link between proto-time, our tau, the sequence, and space-time curvature, r, which is just the shape of space. It means you can never perfectly know both the exact geometric shape of a tiny piece of space and its precise sequence in proto-time. They're fundamentally, quantumly tangled together.
And here's the kicker. Because of this built-in fuzziness between the sequence and the shape, the universe can literally never be static. It can't just sit still. This principle acts like a relentless tiny quantum engine, constantly introducing these little fluctuations that force space-time to evolve and change, always pushing it from one state to the next. It has to move forward.
So let's put it all together. Time to solve the case. We have our two key clues. We've got the primordial clock, that's proto-time, which gives us the sequence, and we have the engine of change, that new uncertainty principle, which gives us the push. Now we can finally see how these two clues combine to forge the arrow of time.
Here's how it all goes down. That quantum geometric uncertainty principle is constantly creating these tiny random fluctuations in the shape of space-time. These changes are then ordered, put into a before and after sequence by the fundamental ticking of proto-time. And because this whole process is quantum and random, it's irreversible. You can't unfluctuate. You can't put the quantum toothpaste back in the tube. And this constant irreversible evolution
ordered by proto-time, well, that is the arrow of time we all experience.
But this leads us to one last question. If the universe is on this mandatory one-way road trip, how does it keep track of the distance it's traveled? How does it measure its own progress from that simple beginning to the incredibly complex cosmos we see today? This brings us to the final piece of this amazing puzzle.
And that measurement is something called geometric entropy. Now, you have to forget the old idea of entropy as just messiness or disorder. That's not what we're talking about here. In the CRM model, geometric entropy is a direct measure of space-time's richness, its complexity. As the universe evolves and creates galaxies, stars, planets, and people, its geometric structure just gets more and more intricate, and so its geometric entropy goes up.
And this is an absolutely critical distinction to make. Geometric entropy is not the engine driving the arrow of time forward. We already know the quantum uncertainty principle does that. No, a better way to think of entropy is as the universe's odometer. It doesn't make the car go forward, it just records how far the car has traveled on its irreversible journey. And so we arrive at the verdict. The real power of this model isn't just in these separate, cool ideas. It's in how they all lock together perfectly. You see, proto-time, the uncertainty principle, the arrow of time, and geometric entropy, they aren't four separate things. They're actually four different views of one single, unified geometric process. Let's just break that down one more time. Proto-time provides the sequence. The uncertainty principle is the engine that forces change. The arrow of time is the result, the journey itself. And geometric entropy is the measurement of that journey, the odometer. You see how they all depend on each other? You can't have one without the others. They're a package deal, all just different facets of space-time's fundamental quantum geometric evolution.
This quote from the source material just sums it up perfectly. The reason time only moves forward, the reason things get more complex, isn't some statistical fluke or a lucky shot from the Big Bang. No, it's a direct, unavoidable consequence of the rules that are woven into the very geometry of space-time. The arrow of time isn't an accident, it's an architectural imperative.
So the whole thing just leaves us with this one massive, mind-bending question. If something as fundamental to our reality as the flow of time just emerges from the geometry of the universe, what else does? Could it be that matter, energy, maybe even consciousness itself are also just different expressions of a much deeper geometric truth? And that is something truly incredible to think about.